So let's look at the homework from last time. I think that was, what was that? 29 to 40, right? Is what we had assigned, I think.
Yeah.
Okay. Kendall.
Can you please do like 32 except?
Sure. All right, so 32 asks us to find the following using the dot product. So the first thing I'm going to do is just rewrite these using the information that's given. So one of the first things that needs to be addressed in this problem is that some of my vectors, specifically u and v, are given in component form. But w is given with those standard unit vectors. So the first thing I'm going to do is either convert everything into a standard unit vector form or everything into the component form. Doesn't matter which one you do. I'm going to convert them into component form. So this is just the component -2, 3. So the i's are just the x, the coefficient on the I is the x, and the coefficient on the j is the y. And the same thing goes to taking something from component form and putting it into unit vector form. Is that okay, Kendall? Okay. So now I'm going to do the scalar multiplications. I don't need that parenthesis anymore. Okay. Then we'll do our vector addition. Okay, there. Now we'll evaluate our dot product. So I got 0 plus 300 or just 300. Nice. Yeah. Yes. Sure. Sure. So 33 is just asking for the magnitude. So in component form, the magnitude is just this. What you have to be careful when you type this into your calculator is to put the parenthesis around the -8 before you press the squared, because the calculator is going to follow the order of operations and do the exponent before the sign. And the -8 squared needs to be a positive number. So this should be 9 plus 64, or just the square root of 73. And if you converted that to a decimal, that would be fine. But I'm guessing that was your issue there, Gisela?
Yeah, I didn't confused.
Do you feel good, though?
Yeah.
Okay.
I'm good, thank you.
You're welcome.
Mr. Kula?
Yes.
Can I go left for my class?
Yeah, go ahead. Kendall, you wanted to look at 35 also?
Yes, please.
Okay. So 35 wants us to find the angle between u and v. So to do that, I'm going to use my angle between two vectors formula. Do you remember what that formula is? Okay. So the formula is the cosine inverse of the dot product over the magnitude of u times the magnitude of v. So that's the formula I'm going to use. So if I was going to do u dot v, that's going to be 3, -8, dot, -4, +5. Gives me -12 minus 40, or -52. Okay there? Okay. We did the magnitude of u just a moment ago as the square root of 73. So I'm not going to rewrite that again, but we just did that a moment ago for Gisela. We also need the magnitude for the vector u. So that's going to be the x component squared plus the y component squared. So 16 plus 25 is 41. So theta is the cosine inverse of -52 divided by the square root of 73 times the square root of 41. And now I'll fire up my calculator to evaluate that. What mode should my calculator be in to do this? Degree mode, since the angle that I'm looking for should be a degree measure. So the way I like to do this when I have to type in a fraction is I'm going to use the shortcut to the fraction command on my calculator. So I'm going to press alpha and the y equals button. And then I'm going to select the first option, the n over d. That allows me to type this in exactly as it looks on my sheet of paper. So it's difficult for me to make a mistake with my parentheses, because what I'm typing in is going to look like exactly what's on my sheet of paper. So my answer for this should be about 161.9 degrees. Kendall, are you okay with what we did there? Okay. So it's just a formula. Now it involves a little bit of work because each of the values in the formula we have to calculate separately with its own separate formula. But then we just plug them back in and type it into the calculator. So it's not so bad. Does that feel better?
Yeah.
Okay. Danny? Sure. So 38 says, given the vertices indicated below, find the side lengths and measures of the interior angles for the triangles below. Okay. This is just kind of a pain in the butt because there's a lot of work to do all these things. But it's all stuff that's doable for us. Okay. So I'm going to start by just sketching myself a picture of what's going on here. So -2, 1. So there's x. -8, -4 is maybe over here. Call that y. And then 5, 7 is like up here, or is it's going to be like up here somewhere. So I think like that's my triangle. It's just really inconvenient. Let me do something better here. Oops. -2, 1. -8, 4. Oops. -4. And then we have 5, 7. Oops. All right. Let's make these easier to find. And then probably want to zoom out just a skosh.
I think it's the line. That's why my graph looks okay.
I don't think it's actually a line. No, it's not actually a line, but it's very, very close. Okay. So what I'm going to do is I'm going to draw something that's just not to scale. So it'll be a little bit easier for us to kind of see. Okay, Danny? So what I'm going to do is I'm going to convert these into the vectors described here. So I'm going to have the vector xy. So that's going to be -8 minus -2, and then -4 minus 1. And then at the same time, I'm also going to write vector yx, because I have a feeling I'm going to need both of them for the angles. Then I'm going to do yz. And then also zy. Sure. I am eventually going to do that. I haven't done that yet. Oh shoot. That should be 5. Sorry. No, what I'm doing right now is I'm converting. Stop talking, please. I'm converting the side lengths of this triangle into vectors, so that I can use the angle between two vectors formula to calculate the interior angles. I do not believe we did this last semester. So I have all of these now. So now I can calculate the side length. So I say, for example, side length xz is going to equal the magnitude of the vector xz, which would be 7 squared plus 6 squared. So 49 plus 36 is 85. Similarly, the length of side yz is going to be the same as the magnitude of the vector yz. That's going to be 13 squared plus 11 squared. 169 plus 121 is 290, I think. Yeah. And then the side length for xy is the same as the magnitude of the vector xy, which was -6, -5. 36 plus 25 is 61. Everybody okay to hear? Yeah, and here's why, Kendall, is if I go back to my picture here, let's find angle y first. So to find angle y, I need yz and yx, right? Okay with that idea? But to find angle x, I'm going to need xy and xz. So that's why I wanted both directions for the vectors, is because I know to do this angle between the two vectors, I was going to need some of them going forwards and some of them going backwards. And I figured I'd just kill two birds with one stone and just do them all at the same time there. Is that okay?
Yeah.
Danny, is that okay?
Yeah.
Okay. So let's go and find angle y then. Did you know there were going to be negatives? Right. So that's why I did it, and did it the long ways, because I didn't want to take... Okay. So in this particular case, yes, the vectors would just be the opposite. You know, the opposite direction would be the opposite signs. But the fact that you didn't know that to start with is why I did it the way I chose to do it. Rather than like announcing some shortcut that you wouldn't have probably not have guessed at. That's why I did it that way. Okay. So this is going to be the cosine inverse of the dot product between, what did we say, yz and yx. Over the magnitude of yz times the magnitude of yx. Okay. So yz dot yx is equal to, let's see, yz is negative 13, negative 11. And then yx is 6, 5. So that's going to be, oops, no vector. See, negative 78 plus negative 55, so that's negative 133, I think. Negative 133 over, and we know yz is square root 290, and we know that yx and xy are both the same length, so it doesn't really matter there. So this is going to be square root 61. So when I type that in then to my calculator, second. And then again, I like to use this fraction shortcut because it makes it a little bit more convenient to type in. Just like you notice that I haven't turned any of these square roots into decimals. Even though I could do that, it makes it less convenient to type it into my calculator, so I've just left them as square roots. That does not seem right at all. Oh, you know what? Remember the picture? That looked almost like a straight line.
Oh, yeah.
So that is probably okay.
So technically.
You're going to have one gigantic angle and two itty bitty tiny ones. So, not surprising anymore.
I mean, it's kind of like...
Danny, did you get the idea now?
Yeah.
Okay. I'm going to omit doing the last two angles just because it's just a lot. Kendall.
Just like, you're just like break it down like in words, like stuff.
Sure. So I converted the side lengths into vectors in component form. Yep, and I did it in both directions. So that's what I mean by opposite vectors. So I did xy and yx. Then I calculated the magnitudes for those vectors, which give me the side lengths. And remember that a vector and its opposite vector have the same magnitude, so I don't have to do that magnitude 6 times. Just doing it once is enough for each in the pair. Okay with that? Then I calculate the angle between each pair of vectors. That's going to give me then the interior angles for this triangle. When I mean pair of vectors, I mean something like xy and xz, where the initial letter is the same. So for angle x, I used xy and xz. So the initial point on the vectors has to be the same as the angle you're solving for. Is that, and that's what we did there in word schedule. Yeah, is that okay?
Yeah.
Or did we run out of time here? Okay. That's okay.